In the summer of 1955, in a stretch of Nevada desert, so remote and so secret that pilots weren't allowed to tell their own wives where they were going, a small team of engineers gathered around a strange-looking aircraft with wings so long and thin they looked like they belonged on a glider, not a warplane. The man who built it, Kelly Johnson, had a reputation inside Lockheed for doing the impossible on impossible timelines, and he had just done it again. But this aircraft wasn't built to outrun enemies or outgun them. It was built to disappear above them, to fly so high that no missile, no fighter jet, and no radar system on Earth could reach it. The problem was that flying that high came with a cost nobody had fully solved, and that cost would nearly kill the men flying it. The story begins with a genuine crisis. By the early 1950s, the United States had almost no reliable way to see what was happening inside the Soviet Union. Stalin had turned the country into a black box, and American intelligence agencies were essentially guessing about Soviet bomber production, missile programs, and nuclear capabilities. Ground agents were being caught and executed. Radio intercepts gave fragments, not answers. President Eisenhower was terrified of being blindsided the way Pearl Harbor had blindsided the country a decade earlier, and he authorized a program that most of the military establishment thought was insane. Build a plane that could fly directly over Soviet territory, take detailed photographs, and come home, all without ever being touched. The number that mattered was 70,000 feet. At that altitude, existing Soviet interceptors couldn't climb high enough, and their surface-to-air missiles didn't yet have the range. Kelly Johnson's team at Lockheed's Skunk Works took an existing jet engine and built the lightest, most fragile-looking airframe they could get away with, stripping out everything unnecessary to save weight, including, in the early versions, basic amenities most pilots took for granted. The wings were so long relative to the fuselage that the aircraft looked more like a sailplane than a jet, because at extreme altitude, in air so thin it could barely support flight, long wings were the only way to generate enough lift. It was named the U-2, a deliberately boring designation meant to disguise what it actually was. But building an airplane that could survive at 70,000 feet was only half the problem. The other half was keeping the pilot alive up there. And this is where the story gets genuinely dangerous. At that altitude, the air pressure outside the aircraft is roughly 2% of what it is at sea level. If the cockpit lost pressurization, or if a canopy cracked, a pilot's blood would begin to boil within seconds, a condition doctors call ebullism. There was no margin for error, no time to react, no altitude to dive to safety before the human body simply began to fail. Standard flight suits used in fighter jets weren't built for this. They were built for temporary exposure during ejection or brief emergencies, not for hours of cruising at the edge of space. So the Air Force turned to the same people who were racing to solve human survival at altitude for an entirely different program: the nascent American space effort. Engineers working on early pressure suit technology adapted their designs for U-2 pilots, creating a full-body suit that could pressurize independently if cabin pressure failed. It had a sealed helmet, multiple layers to prevent the body from swelling under pressure differences, and a system to feed the pilot pure oxygen for hours at a time to purge nitrogen from their blood before flight, preventing decompression sickness, the same condition that gives deep-sea divers the bends. Pilots had to breathe pure oxygen for over an hour before even climbing into the cockpit. Once suited up, they couldn't scratch an itch, couldn't easily reach controls, and were essentially astronauts flying a spy mission years before NASA would send anyone into actual space. When engineers later worked on the Mercury program's spacesuits, they leaned heavily on lessons learned from the U-2 pressure suit, making this Cold War reconnaissance plane an unlikely ancestor of the American space program. Flying the U-2 was miserable in ways that had nothing to do with danger from the enemy. Missions could last 9 or 10 hours, and pilots were sealed into a suit that made basic bodily functions, a genuine engineering problem the Air Force had to solve, with specially designed tubes and containment systems. The cockpit was barely pressurized enough to prevent ebullism, not enough for comfort, so pilots still felt the thinness of the air. Some described the sensation of the suit itself fighting them constantly, since pressurized suits stiffen and resist movement. And because the aircraft was so light and had such a narrow performance envelope at altitude, pilots had to fly within a narrow speed range often described as barely 10 knots wide. Fly too slow, and the wings would stall. Fly too fast, and the aircraft could break apart from stress it was never built to handle. Pilots called this narrow window the Coffin corner, and threading it for 9 hours while wearing a suit built to prevent your blood from boiling was, by any honest measure, one of the most physically demanding jobs in Cold War military service. For 4 years, the gamble paid off. U-2 flights over the Soviet Union produced extraordinary intelligence, revealing missile sites, bomber bases, and industrial capacity that ground agents could never have documented. Eisenhower personally approved individual missions, knowing each one carried enormous political risk if discovered. Then, in May of 1960, everything changed. Pilot Francis Gary Powers was shot down deep inside Soviet territory when a surface-to-air missile finally reached the altitude planners had believed was untouchable. Powers survived, was captured, and the incident became a global embarrassment for the United States, collapsing a planned summit between Eisenhower and Khrushchev, and revealing to the world that America had been secretly flying over Soviet soil for years. The aircraft everyone assumed was invulnerable had a ceiling, after all, and the Soviets had simply needed time to reach it. Despite that very public failure, the U-2 didn't disappear. It quietly became one of the longest-serving aircraft in American military history, transitioning from Cold War espionage to a workhorse for battlefield surveillance, disaster response imagery, and high-altitude scientific research. Remarkably, the aircraft is still flying reconnaissance missions today, more than 70 years after its first flight, having been continuously upgraded with modern sensors, engines, and avionics, while keeping the same basic high-altitude glider concept that Kelly Johnson sketched out in the 1950s. Pilots still wear a version of that original pressure suit lineage, still breathe pure oxygen before flight, and still fly missions that push the human body to genuine physiological limits most people never think about. The U-2 is often remembered as a Cold War relic, a footnote before satellites made high-altitude spy planes obsolete. But its real legacy is less about espionage and more about what it forced engineers to solve: keeping a human being alive and functional at the edge of the atmosphere, in a machine that could kill its pilot through nothing more than the natural properties of air pressure, became a problem that shaped the earliest American spacesuits and, by extension, the entire trajectory of manned spaceflight. The plane built to spy on an enemy ended up teaching the world how to survive somewhere no human had ever been designed to exist.